Hello. So today I have two primary purposes here. Number one, I'm going to do a clarification lecture. Okay. Um, going over some tough stuff. So we're going over statistics. In fact, actually, a lot of your questions were both consistent and also questions that a lot of people, not just in this class, but in general, have difficulty with. So we'll spend some time talking about that. The other of which is what I'm going to talk about first, which is the final paper. Okay. Normally in this class, we have a lot of opportunity to interact with you in person, kind of help guide you guys through your papers, particularly folks who are pushing themselves to do stuff that they find to be challenging, or folks who just don't have a lot of experience with this sort of thing. Um, that was the expectation all throughout the first half of the semester that we were going to have that sort of time, and it was always the hope. But unfortunately, the world's changed, or at least temporarily. And with the way things currently are, we are not able to spend a lot of time chatting with you guys about issues that go into your paper. And as a result of that, I don't want to make this a required assignment anymore. Okay, it is a major assignment in this class, and in the normal instance, I would never step away from this being a required assignment. However, these are not normal times, and I would like to be respectful to the fact that everybody is going through something relatively major. I, however, would like if you feel so up to it, or if you need it for your grade, I'd like people to be able to um, have the benefit of doing the paper. Okay, so if you need the points for your paper, we will not keep you from getting them. In fact, actually, I'm going to switch the paper to being worth extra credit, and actually a relatively high level of extra credit, meaning 50 points. So if you are very disrupted from everything that's happened, odds are this paper can be your life raft. If you just want to challenge yourself and see how you do on the paper, this gives you a great opportunity for there to be no harm, no foul. One way or the other, you're going to get through this, and this is not going to be something that keeps you up at night. Okay. The other major piece that I want to talk about is going through the clarification lecture. Okay. This is tough stuff. So we as behavior analysts, behavioral scientists, a lot of the areas we work in, we're constantly using these single case designs, like what we spent the first half of the semester talking through. Okay. Very cool stuff. However, there are times where that's not what you're going to be able to do. So, for example, if you're dealing with effects that are not going to go away, irreversible effects, we've talked about how to do it within single case designs, but it's actually not really always your best approach. Okay, so if you end up having to use a multiple baseline across subjects, it's actually a relatively not the strongest level of proof that you can come from that. Okay, when it comes to issues of irreversible effects, that's the realm in which group designs have been so helpful over time. Um, Often, there's also issues of convincing your audience. Not everybody understands this stuff. Okay, so if you want to conduct studies in ways in which the general universe is going to understand them, group designs can be very useful. Okay, group designs and statistics can be very useful. There's a lot of reason to know this. In fact, actually, if you are reading stuff that people have done outside of our area, understanding group designs and statistics is useful. So we need to spend a fair amount of time on this to make you both able to make the cases that you want to make, as well as to make it so that you can understand what the rest of the world is doing. Okay, so let's start off a little bit. Start slowly. Okay, if you have come to the point wherein you are going to be comparing across groups. Okay, what you usually do is you get a measure from each individual within the group. Okay, And then you have a distribution of measures in your control group. You have a distribution of measures in your treatment group. So you have your control group, you have your treatment group, okay? And, maybe there's a little bit of overlap, but, each of my fingers, the end of each of my fingers is a data point, okay? And what you can see is, in general, the data points are higher in the treatment group than they are in the control group, okay? However, when you take the average of each of those groups, that's not the whole story, okay? There's a very different story if they're very tightly around the average, as opposed to if they're very, very, very discrepant, okay? And you need to be able to communicate that. In fact, actually, no matter what you're doing, if you're averaging across individuals, across data points, whatever it is, anytime you're averaging, you need to make it clear to people whether your average is a whole bunch of values that are lumped around the mean like that, or if you have a really, really high level distribution amongst those, okay? So anytime you average something, so this isn't even just a group design thing, anytime you're averaging, you need to give some measure of variability, okay? Variability, we're dealing with, oftentimes as an assignment that you do, there's variance. So how far things are discrepant from this. We did this before the break, as well as standard deviation. But you need to, anytime you're representing a mean, an average, you need to show variability. This is particularly important when it comes to comparing groups, because now, when you're comparing those groups, although this difference is small because there's so little variability, that would actually be a remarkable difference. However, with all this extra variability, it wouldn't be a difference at all, okay? So the average difference, the averages between the two groups don't tell you anything. Now you need to be able to know what the distributions are and how representative the average is of those distributions, okay? Then let's get into this general idea of you have to make some conclusions on whether there is a difference or is not between the two groups, okay? Remember, oftentimes this science stuff is about convincing others that you have an effect, okay? And so the null hypothesis, and there's a lot of questions surrounding the null hypothesis, okay? The null hypothesis is that there is no effect, that there is no difference between the two groups, okay? So the null hypothesis is there is no difference between those two there, okay? So the null hypothesis is your buddy who looks at them and looks at something and says, no, there's no difference between those, okay? And what your goal in an experiment is, or no, that's not going to work. That treatment's not going to do anything, okay? Your goal as an experimenter is to figure out if you can say that your buddy's wrong, okay? The null hypothesis, your buddy who's saying that things aren't going to work, your goal in research is to determine whether or not you can say that he's wrong, okay? So let's say you do the experiment and you see huge differences between groups, not that much variability, so it's really clear that there's a difference between the two conditions, okay? The null hypothesis was that there was no difference. However, in reality is you saw a difference. The data that you collected, you saw a difference, okay? The way they talk about this in statistics is they would say that you reject the null hypothesis. You tell your buddy that he's not right, okay? You say, hey, no, there does seem to be a difference between these two, okay? This can be contrasted with the same circumstance where your buddy's like, no, this treatment's not going to work, so that there's no difference between treatment and control. You have your null hypothesis. And you run the experiment, and you don't see anything, okay? In fact, you run the experiment, and it turns out that your control group and your treatment group are identical, okay? Now what you say is, you don't say that that you accepted the null hypothesis, okay? You say that you rejected, or that you failed to reject the null hypothesis. Because the reality is, who knows if you repeated that experiment over and over and over again? If you repeated that experiment over and over again, maybe at some point, or you conducted more, collected data with more and more subjects, maybe at some point you would start to see an effect. Okay, so all you can say is that you were not able to say it was the null hypothesis was wrong. Okay, you cannot say, hey, I accepted the null hypothesis. You can just say that you failed to reject the null hypothesis. Okay, this is the heart of what they call null hypothesis statistical testing. Okay, it's easy to demonstrate that there's a difference between groups. You can never demonstrate that there is no difference between groups, because the reality is if you just start taking more data, you might eventually see a difference between the two groups. Okay, and if you say something doesn't exist, all that has to happen is they have to prove that it does exist. Okay, and that just means more analysis, more measurement, so on and so forth. Okay, that's the null hypothesis. Okay, the null hypothesis is just that there is no effect. And in science, what we do is we essentially make tests to determine whether or not the null hypothesis is true. Okay, now it gets slightly more complicated. Okay, and by slightly more complicated, just a little bit more. And now, this is where we get into the type 1 and type 2 errors. And this is, admittedly, I saw a lot of questions surrounding this on the clarification questions. Okay, so somebody has said, I don't think there's an effect between your treatment and your test, your treatment and your control group. Okay, so they stated the null hypothesis. Okay, and you do the experiment. Okay, and it turns out that you see an effect. Okay, you collect the data that you collect in that experiment, and it turns out that based on the data that you collect, you see an effect. And so you reject the null hypothesis, just like we talked about. However, here's the rub. It turns out that there is, in reality, the fact that the null hypothesis will be true or false. Okay? So if it actually turns out that there is no effect so in reality, so if you collected enough data, so on and so forth, it turns out that there is actually no effect between the baseline, rather between the control and the treatment group. Okay? So maybe you saw a difference based on just some happenstance of the subjects that you ran in this condition versus the subjects you ran in the other condition. You saw an effect, but in reality, there actually is no effect. So you rejected the whole null hypothesis, but in actuality, there is no real effect. Okay? So you said that there is an effect, when in the reality is it doesn't work. Okay? You said a treatment works. In reality, it does not work. Okay? So you rejected the null hypothesis, even though the null hypothesis was actually true. Okay? You said there was an effect when there was not one. Well, that's called a type 1 error. Okay? And to me, the easiest way to remember type 1 versus type 2 error is type 1 is the most important type of error. Okay? Because if you commit a type 1 error, if you're a clinician and you do a quick evaluation of a treatment and you suspect that this treatment works, and you have the child using this treatment on an ongoing basis, that's a pretty big problem. Because now they may or may not walk away from the treatment, because they might just assume that, well, they're not getting the treatment effects because they weren't doing it exactly as you were doing it, so they weren't doing it with proper integrity. One reason or another, it's very hard for people to go back from something that they said was going to work. Okay, it's even worse if you're doing science. So for adding to the scientific literature, because the reality is, if you do a study and it gets out into the scientific literature, it is very, very hard for it to go away. Okay, if you demonstrate an effect, it goes into the literature. It's not just an issue of somebody else going through and failing to find the effect. Okay, because maybe they did. Okay, but the reality is nobody really likes to publish failures to find an effect. Okay, because a failure to find an effect could be that there is no effect there, or it could be that the experimenter failed. It was all it is a failure. Okay, so now you have this one kind of spurious effect that again, You said that there was an effect, and in reality there isn't one. It gets out into the scientific literature, and it is awfully hard to get rid of, okay? So I consider this the type 1 error. Type 1 error is the most dangerous error, okay? Saying there is an effect when there isn't one, okay? Rejecting the null hypothesis when the null hypothesis was actually true, okay? Because the null hypothesis is that there's no effect. Type 2 error, okay? This one's slightly different, okay? Type 2 error. Within the type 2 error, what's happening is you conduct your study, okay? And off the data that you collected, again, you're evaluating this treatment. You think this treatment will work. Your buddy, is the downer. He's the null hypothesis. He says, I don't think that'll work. And you essentially have to prove him wrong, okay? You do the study, and you collect your data, a little bit of data, what's going on. And based off of the data that you collected from the subjects that you had in the treatment versus control group, you go, well, I don't see an effect here, okay? So I'm failing to reject the null hypothesis. But remember, there is an actual underlying truth in nature, okay? And this underlying truth in nature is either a treatment does or it doesn't work, independent of what it shows in your study, okay? And it turns out that this treatment actually does work, okay? And just out of some dumb luck, you ended up with a whole bunch of people in your treatment group that would have been in the lower, the lower group of the treatment group and your baseline group, the higher individuals, and you can't see a difference between the two conditions, okay? So you say there is no effect. So you fail to reject the null hypothesis because you fail to see an effect. Whereas in actuality, the null hypothesis is false. There is actually a difference in nature. Okay? Ooh, that sucks. Okay. However, all that happens in that instance is, so if you're a clinician, you say, I don't think this is a treatment for you. So you move on, you do another treatment. If you're a scientist, you're probably not even going to try to publish those findings. Okay? So it is important because you might be depriving individuals of a treatment that would be effective to them. Okay? As a scientist, you might be depriving individuals of knowledge about the world that would be useful to them. Okay? So I'm not saying that this is unimportant. However, it doesn't have this lasting scar of putting something out into the scientific literature that you can't get rid of, or having said that a treatment works and nobody trusts you anymore because your treatment didn't work. You don't have that scar. So this is a type 2 error, okay? It's a type 2 error. You have failed to reject the null hypothesis when in actuality you should have, okay? Because the null hypothesis was not true, okay? You are saying that there's no effect when there is actually an effect, okay? That's your type 2 error. And I can understand why that's relatively confusing, okay? Now, into a thornier one. And this one, I will tell you, if you have a hard time with this, you are not alone. And that is p-values, okay? So in science, rather, if you're doing statistics, more times than not, so single subject design is actually very unique in that you kind of are putting your own name behind saying whether there's an effect or not within the data, okay? When you use statistics, more times than not, that vulnerability that you have there is actually not there. Because instead, what happens is you just basically have a criteria, and is it statistically significant, okay? And the most common criteria is, when you do your statistics, this p-value pops out, okay? And if the p-value is less than 0.05, you say, hey, that's statistically significant. The p-value is 0.05 or greater, you say, not significant. In fact, actually, to take it to a pure standpoint, 0.05 as opposed to 0.049, you have to say, hey, there's no effect, okay? There is some weirdness that people sometimes do. What they'll do is they'll say, oh, it was approaching significance. You'll You live by the sword, you die by the sword. So if you're doing a group design less than 0.05, hey, you have an effect. 0.05 or above, wah, wah, no effect, okay? But what the heck is this p-value, okay? And this is actually something that throws people off. People will tell you wrongly, sorry, but they will tell you wrongly that it is the probability that this is true, okay? And these are even really smart people who will tell you that, but that's not really what it is, okay? What it is, you have this difference in the data that you have in your treatment group versus your control group, okay? What a p-value tells you is, how likely are you to see that big of a difference between your treatment and your control group if, in fact, there was no effect, okay? So if I see this difference between, the treatment group is much higher than the control group, okay? A p-value of 0.05, or less than 0.05, says that you have less than a 5% chance of obtaining values that discrepant, okay, or at least that discrepant from each other between the two groups, so that different between the two groups, if there was actually no effect, okay? It's somewat challenging, but it's important to get it right in terms of what the p-value is, because if the p-value is not that, rather if you misinterpret what a p-value means, you can misinterpret what research findings are telling you, okay? Again, this one is not unusual. This one's pretty normal. You're in good company if you have a hard time with that. There was a question or two, just some small pieces in the back end here. The question or two about standard deviation variance. Variance is just basically how far everything is from the mean. Okay, so you have your mean, you have your distribution around the mean, how far the values are away from the mean. Because some will be above, some will be below. You have to square those, and so your variance is the squared differences. So the average squared difference between your data point and the mean. Okay, smaller variance, less variability. Okay, the standard deviation is, and I believe we did this as an assignment. The standard deviation is just the square root of that. So now you're taking that squaring piece away, but you have to square it so that you don't end up having the positive and the negatives, balancing it out. Okay, and the other detailed piece that popped in were confidence intervals. Okay, confidence intervals have to do with in a distribution of values, X% of the values fall between, or you're expecting that within the population, based on the sample of values that you have here, that 95% confidence intervals are saying that 95% of the values should be between this lower and higher limit. Okay, if you don't have overlap in your confidence intervals, it suggests that there's probably a difference between two groups. This stuff is hard. More than anything, we just want to make sure you have an understanding of how this stuff works before you go forward. And I'm hoping that everybody's doing well. I sincerely hope you guys are doing well. This is an unusual time, and we hope that we all can be happy and healthy and get out of this okay. Talk to you guys soon. Thanks.